Accompanying a meal, with a good glass of wine, or having a few drinks on Saturday night in the disco, is for many, one of the essential pleasures of life. There are those who drink just a glass on great occasions, such as birthdays, or the end of the year, but also those who, to combat boredom, or have fun, consume high quantities of alcohol at the weekend, or even worse throughout the week. Unlike what many believe, alcohol is not a nutrient, such as carbohydrates, proteins, and fats, and therefore it is not useful to the body, much less to its functions. Among the innumerable damages caused by alcohol consumption, in this video we will analyze those on the brain. Contrary to what people think, although alcohol may initially cause a feeling of euphoria, it is actually a severe central nervous system depressant. It inhibits the receptors for excitatory neurotransmitters and enhances those for inhibitory neurotransmitters. When we consume alcohol, it is absorbed by the stomach and intestines. It ends up in the blood and reaches the brain, managing to cross the blood-brain barrier. It is a structure that protects the brain from poisoning and intoxication, and does so by regulating and controlling the blood flow of chemicals to the brain. The alcohol, in the meantime, is then metabolized by the liver, which produces a toxic and carcinogenic substance called acetaldehyde. Ethanol and its metabolite are substances that have a direct toxic effect on neurons, causing permanent structural and functional damage. It can interfere with neurogenesis, that is your body's ability to generate new brain cells. When we drink ethanol, it is rapidly absorbed and acts on neuronal circuits, inhibiting or activating them. We know that the brain contains neurotransmitters, which are chemical messengers that neurons use to communicate to transmit nerve impulses. Alcohol acts on the receptors of some neurotransmitters, known as dopamine, glutamate, and GABA. Alcohol enhances the inhibitory activity of GABA receptors, and increases the excitatory activity of glutamate receptors. GABA is the main inhibitory neurotransmitter, meaning it reduces neuronal excitability and slows down electrical impulses. Alcohol binds to its receptors, causing us an anxiolytic effect. Furthermore, they slow down our reflexes and thoughts, and we say things we would never say when sober. Glutamate, the enemy of GABA, is instead an excitatory neurotransmitter. Alcohol manages to modulate it, inhibiting its activity in parts of the brain, such as the prefrontal cortex. This causes behavioral disinhibition, self-control, and judgment. Alcohol raises dopamine levels, and causes that rewarding feeling in the brain, which is the basis of the instinct to continue drinking. Dopamine, is involved in the gratification and motivation circuits. As alcohol consumption continues, the brain adjusts to the high levels of dopamine present, and begins to produce less naturally. It is precisely in this way that alcohol addiction arises, and if you stop drinking, withdrawal symptoms arise. The slowness and the difficulty of coordination are instead explained by the effects of ethanol on the receptors for glycine, an amino acid with inhibitory neurotransmitter functions of the central nervous system. Alcohol can also negatively impact the health of other vital areas of the brain, namely, the cerebral cortex. The thinking center of our consciousness, fundamental for the processes of planning, control, and execution of the voluntary movements of the body. Alcohol depresses this area, slowing the communication of sensory information, clouding the thought process, and reducing inhibitions. The cerebellum is the center of movement, coordination, and balance. Alcohol causes instability, makes our hands shake, stagger, increasing the risk of falling. The pituitary, hypothalamus, and central nervous system. Alcohol depresses and alters the functioning of the endocrine and nervous systems. By examining the long-term effects of alcohol on the brain, we can see how it can cause permanent damage to the brain structure. One of the most in-depth studies was conducted by scientists at the University of Oxford, with a 30-year monitoring, analyzing the drinking habits of over 25,000 people in the UK. Their brain magnetic resonances were studied, arriving at the conclusion that in alcohol users, even moderate ones, there is an up to 6 times greater risk of hippocampal shrinkage, compared to those who do not take even a drop. The hippocampus is a brain structure that owes its name to its seahorse shape. Its role is fundamental, as it is involved in the preservation of long-term memory. According to the study, alcohol also affects the white matter, i.e. those nerve fibers that connect the brain to the spinal cord, compromising some functions, including language. Not even the gray matter is spared from the effects of alcohol, nor the neurotransmitters, which if damaged, slow down the communication between the different areas of the brain. Brain damage from alcohol consumption is more severe in young people, as the brain is still developing, and in the elderly, who by age are already at a greater risk of developing psychiatric disorders and neurodegenerative diseases. Alcohol therefore remains a toxic substance, potentially carcinogenic, and capable of inducing addiction. It is not possible to identify recommended or safe quantities of alcohol for health.